What's going on, guys? Let's do this problem right here. We have this pipe right here. Here's small diameter, and we have high diameter, right? Big diameter. And here the question is asking pressure 2. Pressure 1 is provided, and the velocity 2 in this area, right? So let's see how we can calculate this one. In this case, we have to use the Bernoulli's equation to calculate this equation. So the Bernoulli's equation is going to be P1. So I'm using the pressure equation, P1 rho G H1 plus half rho V1 square equal to P2 plus rho G H2 plus half rho V2 square, right? So this is the equation. And here the height is same. If you look at this from the reference point, we are taking the middle part. So the height is similar, so we can cancel these two. And we left with P1, P2 and these things. Our purpose is to find the P2, but before that we had to know this V2. So we have a V2 right here, so we have to know the V2. Let's see. So here, this is, let's say this is D1, D2, okay. So area, if this is area 2 and if this is area 1, area 2 is going to be equal to area 1 times diameter 2 divided by diameter 1 square. So this is the connection we can make from this one, and let's plug all the values. We have A1 times D2, that is known, 10 square divided by D1, that is 5 square. So 5 square, that's going to give us 100 over 25, that's going to be 4A1, right? 4A1. Therefore, so 4A1, okay. A1 V1, the volume flow rate is going to be equal to A2 V2, right? A2 V2, and that's going to be, therefore V2 is going to be equal to A1 V1 divided by A2. We already know that A2 is equal to 4A1, so we can plug that one right here. A1, okay, A2 is equal to 4A1. A1 V1 over 4A1. So A1 cancels. We have 4 right here. We already know the V1. V1 is here 4 meter per second. So this is going to be cancelled with this one, and therefore V2 is going to be equal to 1 meter per second. So we have the V2 right now. Let's find the P2. So here V2 is equal to 1 meter per second. To find the P2, I have to rearrange this equation. So P2 is going to be equal to P1 plus half rho V1 square minus half rho V2 square, right? That's the equation. P1 is known, that is 2 atm, and then we have half rho V1 square. We can take half rho common. We take half rho common. We have V1 square minus V2 square in the bracket. So let's calculate this one. 280 m plus half, density of the water is 1000, so that's going to be 1000. Here we are going to have V1 square 4 square, this is going to be 16 minus 1 square 1, and we get 280 m plus 500 times 15. This is in atm, this is in Pascal, right? We have to convert this one into Pascal. We know that 1 atm is going to be equal to 100,000 Pascal, like 101.500 second. So let's convert this Pascal into atm. If I convert this one gives us 0.074 atm. Therefore the final answer is going to be 2.0 2.074 atm. That is the pressure 2. So pressure 2 is equal to 2.074 atm, and that's how it's done. I hope you guys like this video. See you next time.